Hello students, welcome back to NEET Masterclass with Sparkl. So today I have come up with the topics ray optics, wave optics and dual nature. Though wave optics and dual nature are very easy, a limited number of questions are formed on this particular chapters. Little practice can ensure that a similar kind of question will be asked in the exam. Ray optics, on the other hand, sometimes in some cases feels tough, but if you see it topic wise, like you see total internal reflection, you see prism, and you see the optical instruments part, it is purely formula based, and two questions are definitely asked from these topics only. One question can be asked either from mirror or the lens portion, though it has formulas and sign conventions, but if you practice it, then it gets easier. So let's start with the problems that I have brought today are in line with what NTA asks, in line with the PYQs, and you can accept similar questions in your re-NEET exam this year. So let's start with the first question. A double convex thin lens, a double convex thin lens is made up of glass, has both radii of curvature 20 centimeter. Incident light rays parallel to the axis converge at a distance L. So when there is a convex lens and there are parallel rays, they will converge at the focus. So in this question, this L will be the focal length basically. Now we know that the focal length is equal to R upon 2 into n minus 1, and for a double convex thin lens, when we put the value of n is equal to 1.5, this will become R. So our answer will be 20 centimeter. Now you have to remember that if you are given a biconvex lens of glass, you can directly write that f will be equal to R. If it is a biconcave lens, the focal length will be minus R. So focal length will be plus minus R for a glass lens, and which is a biconvex or a biconcave lens. Okay, for a plano-convex and a plano-concave lens, it will become 2R. Okay, the focal length becomes twice of the radius of curvature. So moving to the next question. A lens behaves as a converging lens in air and a diverging lens in water. The refractive index of the material is. All right. So it is behaving like a converging lens in air. So let's hope it's a true nature. So it's a convex lens basically. So its refractive index will be greater than 1. Now a diverging lens in water. So its nature reverses. अब नेचर रिवर्स कब होता है? नेचर रिवर्स तब होता है जब हम ऐसे मीडियम में लेंस को पुट करते हैं जिसका रिफ्रैक्टिव इंडेक्स लेंस के रिफ्रैक्टिव इंडेक्स से ज्यादा है. तो रिफ्रैक्टिव इंडेक्स ऑफ द सराउंडिंग इज ग्रेटर देन रिफ्रैक्टिव इंडेक्स ऑफ द लेंस. सो इट इज वाटर. सो 1.33 is greater than NL. So NL is greater than 1 and less than 1.33. So this will be my answer. So all you have to remember here is whenever we put a lens in a medium which has a greater refractive index than that of the lens, its nature will get reversed. If the refractive index of surrounding is less than the refractive index of the lens, then it will exhibit its true nature of convergence or divergence, whatever. Okay. Next question. In displacement method, there are two positions of lenses for which we have real image of one pin over another placed at a fixed distance. The first position of the lens is 45 and the second position is 90. So from here we can see that D will be equal to 90 plus 45. Okay, it will be 135. And X, which is the distance between the lenses, we can also draw the diagram if you want. So this is the pin and this is the screen, and these are the two positions of the lenses. It's a convex lens. So one is 45 and one is 90. So if this is 90, this will become 45. So D will be equal to 135 and X, the distance between the two positions, will be 90 minus 45. So it will be 45. So we are asked the focal length. We can directly use the focal length formula. It will be equal to d square minus x square upon 4d. And if we solve it, just put the values. 135 square minus uh, 45 square upon 4 into 135. So taking 45 square common from over here, it will become 3 square minus 1. So 8 it will become upon 4 into 135. All right. So this will go like 3 times. This will be 15 and this will be 2. So the answer comes out to be 30 centimeter. So again, a purely formula based question. This displacement method is a practical method, and it's been seen that NTA is very much obsessed with these practical methods. So you can expect a question from this particular portion. So you have to do it very thoroughly. I have included some more questions on this. So we'll do them. Unpolarized light is incident from air on a plane surface of material or refractive index mu at a particular angle of incidence I. It is found that the reflected and the refracted rays are perpendicular to each other. तो ब्रूस्टर्स एंगल की यहाँ पर बात हुई है. तो इस केस में तो जो रिफ्लेक्टेड लाइट होती है वो पोलराइज्ड होती है एंड इट्स इलेक्ट्रिक फील्ड वेक्टर इज परपेंडिकुलर टू द प्लेन ऑफ इंसिडेंस. सो दिस विल बी द आंसर. दिस हैज बीन आस्क्ड इन PYQs. ठीक है. Young's double slit experiment is performed in air and then in a medium other than air. It is found that eighth bright fringe of the medium lies where fifth dark fringe lies in the air. So let's see where will be minima, y5. So minima का expression जो होता है वो 2n minus 1 into lambda capital D upon small d होता है. ठीक है, by 2. ठीक है. तो यहां से हमारे पास आ जाएगा n का वैल्यू 5 रख देंगे हम y5. तो इट विल बी 9 lambda capital D upon 2d. Okay. Now, when we do it in medium, the wavelength will become lambda by mu. All right. So, and यहाँ पर हमें बात करनी 8th मैक्सिमा की. So, y8 in air पहले निकाल लेते हैं. So, it will be 8 lambda capital D upon small d. And जब मीडियम में करेंगे y8 मीडियम, तो it will become 8 lambda capital D upon mu d. Now, ये दोनों कोइंसाइड कर रहे हैं, हमसे क्वेश्चन में बोला है, तो देयर वाइज विल बी सेम. So 9 lambda capital D upon 2d will be equal to 8 lambda capital D upon mu d. So all the variables will get cancelled, and mu from here will become 16 upon 9. All right. And it will become 1.78. So it's an easy question. You just have to remember the formula for minima and that for the maxima. So I told you that wave optics mein there are certain types and varieties of question. If you do these varieties, definitely a similar question will be asked in the exam. All right. Next question. The interference pattern is obtained with two coherent light sources of intensity n. The interference pattern, the ratio I max minus I min upon I max. This is a direct formula and this is the answer. This comes out to be 2 under root of n upon n plus 1, where n will be the intensity ratio. So you can directly learn this formula and put the values over here. We have done this in waves also, and I told you that similar question can be asked in wave optics, right? The intensity at maximum in a Young's double slit experiment is I naught. So this is my I max. Now distance between two slits is 5 lambda, and lambda, where lambda is the wavelength of the light used in the experiment. What will be the intensity in front of the slit on the screen placed at a distance 10d? So we are asked about intensity in front of the slit. So let's say these are our two slits, and this is our screen. So let's draw the diagram. It will make things easier for us. This is the center, and this is the central maxima over here. Okay. Now, this distance is equal to 10 small d, or it is 50 lambda. All right. This is 5 lambda over here. Now, in front of the slit, this will be the y, and y will be equal to how much? 2.5 lambda. So, हमें intensity निकालनी है. Whenever intensity is asked, we have to find the phase difference. And phase difference कैसे निकलेगा? Path difference है. So, we have to find the path difference first, देन फेज डिफरेंस, एंड वहां से हमें इंटेंसिटी निकालनी होती है. जब भी इंटेंसिटी क्वेश्चन में पूछिए, यू हैव टू फाइंड द फेज डिफरेंस समहाउ, एंड वो हम पाथ डिफरेंस से निकालते हैं. तो अब हमें इंटेंसिटी कहाँ पे निकालनी है? एट y इज इक्वल टू 2.5. सो लेट्स फाइंड आउट द पाथ डिफरेंस फर्स्ट. सो पाथ डिफरेंस का फॉर्मूला होता है y स्मॉल d अपॉन कैपिटल D. लेट्स पुट द वैल्यूज. सो इट विल बिकम 2.5 lambda into d is 5 lambda upon capital D is 50 lambda. So this comes out to be 10, and this will be 0.25 lambda, or lambda by 4. So path difference comes out to be lambda by 4. Now delta phi is equal to 2 pi by lambda into delta x. So delta phi will become 2 pi by lambda into lambda upon 4. So it will be pi by 2. All right. So the phase difference is pi by 2. वहां पर हमें इंटेंसिटी निकालनी है. अब इंटेंसिटी जो होती है वो I max into cos square delta phi by 2 होती है. तो I max is I naught into cos square 45 it will become. So it will become I naught upon 2. So this will be my answer. All right. So there are a few things, like एक intensity मैंने बता दिया कि you will have to find the phase difference. In front of the slit, मतलब y will be equal to d by 2. In front of the slit, y will be equal to d by 2. Okay. So this is what you have to remember, and in the questions just draw the diagram, so you'll get a better understanding, and गलती होने की आपकी probability जो है वो minimum हो जाएगी. All right. So next question. At the first minimum adjacent to the central maximum of a single slit pattern, the phase difference between Huygens wavelet from the edge of the slit and the wavelet from midpoint of the slit is. So basically it is pi. All right. The phase difference between edge and the midpoint of the slit is y, because path difference between the edge and the midpoint is lambda by 2. All right. सो ये आपको याद रखना है कि द फेज डिफरेंस बिटवीन द वेवलेट एट द मिड पॉइंट एंड द एज जो होता है वो पाई रेडियंस के बराबर होता है. जस्ट रिमेंबर दिस. ओके. बिकॉज द पाथ डिफरेंस अगर आप देखेंगे तो इट इज लैम्डा बाय 2. ठीक है. फॉर अ पैरेलल बीम ऑफ मोनोक्रोमैटिक light of wavelength lambda, diffraction is produced by a single slit whose width is a. So this is about the diffraction, and slit width is a. This is the screen. So here it is a, and a parallel beam of light is over here, incident over here. If d is the distance of the screen from the slit, the width of the central maxima. So the angular width of central maxima is 2 lambda by a. We know it, angular width. Now theta, we can write it as y upon d is 2 lambda by a. So y becomes 2 lambda capital D upon a. So this is a direct formula again, but in diffraction या तो फर्स्ट मिनिमा के बारे में पूछते हैं या मेजरली वो सेंट्रल मैक्सिमा के बारे में पूछते हैं. तो दिस इज द क्वेश्चन यू कैन एक्सपेक्ट फ्रॉम ओवर हियर. Easy question. You just have to remember the formulas. In Young's double slit experiment, the intensity of light at a point on the screen where path difference is lambda is k. The intensity at a point where the path difference is lambda by 4 will be. All right. So again, the intensity is asked. So for intensity, we need to find the phase difference. For that, we need to find the path difference. All right. So path difference हमें पता है कि at a point where the path difference lambda इस के इंटेंसिटी वहां की दे रखी है, तो आई मैक्स बेसिकली हमें दे रखा है के बराबर। ऑलराइट, अब जहां पे लेमदा बाय 4 होगा पार्ट डिफरेंस, तो फेज डिफरेंस कितना हो जाएगा, 2 पाई बाय लेमदा इंटू लेमदा बाय 4, so it will again come out to be pi by 2. Now intensity is I max into cos square delta phi upon 2. It will become k into cos square 45 or k by 2. So this will be my answer. So again, it's a direct question on finding the intensity, and उसमें हमें क्या करना है, we have to find the phase difference and apply this formula. In Young's double slit experiment, the slits are 2 mm apart and are illuminated by photons of two wavelengths lambda 1 and lambda 2. At what minimum distance from the common central bright fringe on the screen 2 meter from the slit, the interference pattern coincide? See, if the interference pattern is coinciding, हमें पता है कि y दोनों के लिए सेम होगा, y1 will be equal to y2. तो उससे हम लिख सकते हैं n1 lambda 1 will be equal to n2 lambda 2. Okay, so this is what you have to do here. So let's say कि n1 into 12,000 will be equal to n2 into 10,000, and if we do this it will become 6 and 5. So n1 into 6 will be equal to n2 into 5. Now, what will be the minimum value of n1 and n2? So, if this becomes 5 and this becomes 6, they will become equal. So, n1, let's say हम 5 से बात करते हैं, okay? वो दोनों की bright fringe है, तो फर्स्ट वाले के लिए अपन y5 निकाल लेते हैं, तो y5 जो हो जाएगा वो 5 इंटू लेमदा 1, दैट इज 12,000 इंटू 10 to the power -10. Capital D is 2 upon small d, 2 into 10 to the power -3. So if we solve this, I'll get 5 mm. Sorry, 6 mm. This will be my answer. 5 into 12, 6 का number मिलेगा. All right. So this is how we have to do this. So coincide जहां भी करने की बात आती है, मतलब पैटर्न coincide कर रहे हैं, मतलब their y's are same. दोनों मैक्सिमाज हैं अगर, तो n1 lambda 1 will be equal to n2 lambda 2 because y will be n lambda capital D upon small d. All right. Next question. Two periodic waves of intensities I1 and I2 pass through a region at the same time in the same direction. The sum of maximum intensity and minimum intensity. So I max is basically I1 plus I2 plus 2 under root of I1 I2. I minimum is I1 plus I2 minus 2 under root of I1 I2. If we add them, so I max plus I minimum will become 2 into I1 plus I2. All right. So this will be my answer. All right. Moving to the next question. In Young's double slit experiment, if the distance between the two slits is halved and the distance between the slits and the screen is doubled, the fringe width becomes. So fringe width कितना होगा, lambda capital D upon small d. This is my expression for fringe width. Now the distance between the slits is halved. So this is halved, and the distance between the slit and screen is doubled. So this is doubled. So mu will be 4 times. This will be my answer. All right. Next question. Ultraviolet light of wavelength 2000 angstrom causes photo emission from a surface. The stopping potential is 2 volt. The maximum speed of the photoelectron is. So if we want to find the maximum speed, so half mv square, v max square will be equal to E into V. This is what we have to do. So it will become half of m 9.1 into 10 to the power minus 31 into Vm square is equal to 1.6 into 10 to the power minus 19 into 2 it will become. All right. And if we solve these things, I'll approximately get Vm will be equal to 8.4 into 10 to the power 5 meter per second. So, though there is a little calculation over here, but the question is very easy that we have to find V max. So it will be equal to EV. All right. Yeah. Next question. Maximum kinetic energy of a photoelectron is E when the wavelength of light incident is lambda. Okay. So K max is basically what? Hc by lambda minus phi. This is the expression for K max over here. All right. Now, the maximum kinetic energy of a photoelectron is E when the wavelength of light lambda is used. So E will be equal to Hc upon lambda minus phi. The energy becomes 4 times when the wavelength is reduced to 1/3. Then find the work function. So energy कितने times हो गई? 4 times हो गई. So 4E, वापस फिर से यही फॉर्मूला लिख रहे हैं. On lambda is reduced to 1/3. So it will become lambda by 3 minus 5. So it is 4E is equal to 3 Hc upon lambda minus 5. Okay. तो हम ये करते हैं, दिस इज माई इक्वेशन 1 एंड दिस इज माई इक्वेशन 2 एंड वी हैव टू कैंसल आउट थिंग्स. एंड देखो एच सी बाय लेमदा के फॉर्म में आंसर है तो हमें ई का वैल्यू कहीं ना कहीं सब्सटीट्यूट करना है. तो लेट्स पुट द वैल्यू ऑफ ई ओवर हियर. So it will become 4 into Hc by lambda minus 5 is equal to 3 Hc by lambda minus 5. 4 Hc by lambda, 4 Hc upon lambda minus 4 phi will become 3 Hc upon lambda minus 5. So we bring the similar terms here. So if we bring it here, it will become Hc by lambda is equal to 3 phi and phi will be equal to Hc upon 3 lambda. So this will be my answer. Okay. So you have to use this particular equation only and find the answer. And you have to see कि options किस form में दिए हुए हैं. E के form में दिए होते तो हम Hc by lambda को eliminate करते, because they are given in form of Hc and lambda, so हमने E को eliminate किया. Alright. So कुछ भी हो सकता था उसके बीच में. Okay. Next question. So maximum speed of the photoelectrons emitted is proportional to. So this is frequency mu. So K max we can write as h nu minus h nu naught. This is the threshold frequency. So half mv square is equal to h nu minus h nu naught. So from here v will be proportional to under root of nu minus nu naught. So again, a easy question. Just have to remember the formula. Next question. Monochromatic photons, each of energy phi electron volt, are incident on a photosensitive plate of work function 2 electron volt. The kinetic energy is. तो K max जो होता है वो E minus phi के बराबर होता है. So it is basically phi minus 2 electron volt. So 3 electron volt. So see, the maximum kinetic energy is 3 electron volt. All right. अब कोई भी फोटो इलेक्ट्रॉन होगा तो उसकी जो काइनेटिक एनर्जी है वो 0 से 3 इलेक्ट्रॉन वोल्ट के बीच में कुछ भी हो सकती है. ऑलराइट. दिस इज द मैक्सिमम. So it can have 0, it can have 0.5, 1, 1.5, whatever, cannot exceed 3. So it will be between 0 and 3 electron volt. All the photoelectrons will have in this range only. Okay. Next question. When light of wavelength 400 nanometer falls on a photoelectric emitter, photoelectrons are just emitted. Okay. when they are just emitted, what will happen is कि वो हमारा थ्रेशोल्ड के बराबर ही हो गया फिर तो, ठीक है। तो हमें पता है कि एच सी अपॉन लेमदा नॉट इज इक्वल टू 5, ठीक है। जब जस्ट निकला है तो ई काइनेटिक एनर्जी को मैंने जीरो मान लिया, तो दिस इज व्हाट आई गेट। सो 5 1 आई कैन राइट इट एज एच सी अपॉन, जब मैंने 400 यूज किया, and 600 nanometer is sufficient for liberating photoelectrons for another emitter. So phi 2 will be equal to hc upon 600. Now I have to find the ratio of work functions. So it will become hc upon 400 upon hc upon 600. So it will become 3 by 2. All right. Next question. So when the monochromatic photons of wavelength 400 angstrom are incident on a metal plate of work function 2.1 electron volt, the stopping potential. So again, it's a purely formula based question. E into Vs will be equal to Hc by lambda minus phi. So let's write it. So it will become 12400 upon 4000 माइनस 2.1 इलेक्ट्रॉन, ये इतना इलेक्ट्रॉन वोल्ट हो जाएगा यहाँ से, तो दिस विल गेट कैंसल्ड। नाउ 124 अपॉन 40 will somewhere become 3.1 around. So Vs will be equal to 1 volt. Okay. So again, a simple formula based question. Okay. Yeah. When energy of incident radiation is increased by 20%, the kinetic energy of most energetic electrons is increased from zero point 0.8 electron volt to 1.10 electron volt. The work function of the metal is. Okay. So we have to, do it. So kinetic energy, let's say it is K. So पहले जब के मैक्स जो था, अच्छा काइनेटिक एनर्जी तो 0.8 एंड 1.10 हमें दे रखी है, द एनर्जी ऑफ इंसिडेंट। सो लेट्स से द इनिशियल एनर्जी इज ई ओनली, सो ई माइनस ऑफ 5 is equal to 0.80 electron volt. This is my first equation. Now when energy is increased by 20%, so it will become 1.2 e minus 5, it becomes 1.10 electron volt. So from here, what we need to do is we need to find the value of phi. So we'll have to eliminate E over here. So let's put the value of E. So 1.2 into E will become 0.80 plus phi. Okay. Minus phi is equal to 1.10 electron volt. Okay. And when you solve it, you will get phi will be equal to 0.7 electron volt when you solve this. So again, a easy question. You have to do what the question has told you. And in this chapter, यही एक फॉर्मूला है, इसी को बार बार ट्विस्ट करके एंड ऐसे यूज किया जाता है। तो दिस इज व्हाट यू हैव टू रिमेंबर इन दिस पर्टिकुलर चैप्टर, एंड it's very easy. It's very easy, right? So coming to the next question. A ray is incident at an angle of incidence I on one surface of a small angle prism and emerges normal from the opposite surface. If the refractive index of the material of the prism is mu, the angle of incidence is nearly equal to. Okay. So let's draw the diagram. It makes things easier for us to do. So I have an incident ray at an angle of I like this, and it is said that it is a small angled prism, angle of prism is A, and it emerges normally on the opposite surface. So it emerges like this. Okay. So From over here, we can see that this is I, this is R. So this will be 90 minus R. This will be 90 minus R. This will be 90 degree. So we can say that A plus 90 minus R plus 90 will be equal to 180 degree. Okay. So we get the value of R will be equal to A. Now applying Snell's law over here, so I can write that 1 into sine of I will be equal to mu is the refractive index of the prism, mu into sine of R, or R will be equal to A. Now, because the angles are very small, like A is small, so we can write that sine theta is equal to theta. Okay, so I can write I is equal to mu into A simply. This will be my answer. So again, a easy question. A rod of length 10 centimeter lies along the principal axis of a concave mirror of focal length 10 centimeter in such a way that its closer, its end closer to the pole is 20 centimeter from the mirror, the length of the images. All right. So, this question may be, if you want to do it correctly, first we have to draw the diagram. So, this is my mirror. All right. Now, the focal length is 10 centimeter. The center of curvature is 20 centimeter. Now there is a rod of length 10 centimeter lying on the principal axis of a concave mirror in such a way that the end closer to the pole is 20 centimeter from the mirror. So this rod also is kept over here only, and its one end is at 20 centimeter or at the center of the curvature. So it makes things easier for us. Its length is 10 centimeter. So see, when one end, let's say A and B, one end is at 20 centimeter, which is the center of curvature. So its image A dash will also be formed on the center of curvature. So it will be 20 centimeter only. Now this end B, इसका distance pole से क्या होगा? It will be 30 centimeter from the pole. Now we have to find B dash की इसका image कहाँ बनेगा? Alright. तो उससे हमें लेंथ पता चल जाएगा. तो आप समझ गए होंगे क्वेश्चन डायग्राम देखकर. तो यहाँ से u we are given as -30 for end B we are solving. -30, focal length is minus of 10 centimeter. All right. And mirror formula is 1 by V plus 1 by U is equal to 1 upon F. So, or we can write V is equal to UF upon U minus F. This is also an important formula that you can remember. So we'll just put the values with signs according to the sign convention. So U will be -30 into -10 upon -30 minus of -10. So it will be 300 upon minus of 20. So V will be equal to minus of 15 centimeter. So see, what happens is this B dash will be 15 centimeter from the pole. All right. So it will be formed somewhere over here. So this is B dash. So the length of this length will be how much? 5 centimeter. All right. Length will be 5 centimeter of the image A dash B dash. This A dash B dash will be of 5 centimeter. So this will be my answer. All right. Yeah. Again, optical fiber पर एक theoretical question है. So we know that optical fiber ऐसे कुछ होता है, and it has got layers like this. ये जो inner part होता है जहाँ से कि light travel करता है, that is the core. So it is the core, and इसका एक protective layer होता है, उसको बोलते हैं cladding. So अब TIR होने के लिए लाइट डेंसर से रेयर मीडियम में जानी चाहिए, तो कोर मस्ट बी डेंसर, राइट. तो यहाँ पे जाए ना लाइट. ओके. सो द कोर विल हैव अ ग्रेटर रिफ्रैक्टिव इंडेक्स देन द क्लैडिंग. ठीक है. रिफ्रैक्टिव इंडेक्स ऑफ द कोर विल बी ग्रेटर देन दैट ऑफ द क्लैडिंग. सो दिस विल बी माय आंसर. ओके. Again, a TIR question, a standard question. It can be found in like every book or package. Very common, but yet very, very, very important. It's very likely that this question can be asked in the exam this year. Okay, so it's a standard question. A small bulb is placed at a depth of 7. So this will be my depth, and a floating opaque disk is placed over the bulb so that the bulb is not visible from the surface. The main diameter of the disk is, okay, so uh, let's draw a bulb over here, and the light from the bulb should not exit, so it should suffer TIR at both, uh, everywhere over here, and the disk can be placed like this so that light will exit only from this region, this conical, but we have placed a disk, so from there also the light will not exit, and we have to find the radius. So let's say the radius over here is r, okay, and this depth is h. Now this is the critical angle over here, this is also theta c. So we know that tan theta c will be equal to r upon h. Okay, this is what it will be. This is r, this is theta c, perpendicular upon base. All right, now we have to find the value of sine theta c over here. So sine theta c, as it is the critical angle, will be 1 by n. So we can write it as 1 and n, and it will be under root of n square minus 1. So tan theta c will be equal to under root of 1 upon n square minus 1. So from here we can put the value under root of n square minus 1 is equal to r upon h. So the radius will be equal to h upon under root of n square minus 1. So you can learn it as direct formula as well, and or you can derive it like this. So radius will become, height is 2 root 7 upon under root of, this will be 16 by 9 minus 1. Okay, so this will come out to be 6 meters. So we have to find the diameter. So diameter will be 12. So our answer comes out to be 12. The radius will be 6. The answer will be 12 meters. All right. So these are some questions that you need to do very carefully from each of the chapters. Also, I have mentioned the topic, especially in ray optics, that you have to master the questions on optical instruments, you have to master the questions on TIR and the prism, and do all the standard questions that are there in wave optics and dual nature. That's what we have tried to do today. So let's meet again in the next lecture with next set of chapters and similar orientation, similar thought process of NEET. And let's hope that some of the questions that I have taught here will be asked as it is, or similar questions will be asked in the NEET exam. So all the best, keep practicing, do your best. Let's meet in the next class. All right. Thank you.